A very good afternoon and welcome back. A very good afternoon and welcome to our third session of Frontiers in Biological Sciences, Chapter 4, 2020. And the topic for the session still remains the same, COVID-19, the current scenario. And I would request our professor, Dr. Kasturi Sarkar, to introduce our penultimate speaker, Dr. Shashirekha Mundhra. Ma'am, on to you. Thank you.
Thank you, Maitri. Good afternoon to everyone attending Frontiers in Biological Sciences 2020, Chapter 4, an international webinar on COVID-19, the current scenario. Our speakers, guests, colleagues, friends, and students, welcome to the program of Day 2, Session 3. Today's session begins with a talk of Dr. SHASHIREKHA Mundhra, and I have got the pleasant duty of introducing her to you. If I go 14 years back, in 2006, 1st of July, St. Xavier's College got its autonomous status from University of Calcutta. On the same day, I joined Department of Microbiology as a faculty member, and a young, lovely, intelligent girl in her teens joined the same department as an undergraduate student. We started our journey at St. Xavier's together, and the girl, Shoshi, as we used to call her, is today's first speaker, Dr. SHASHIREKHA Mundhra. So it is a proud moment for me to introduce Dr. SHASHIREKHA Mundhra to you and to welcome Dr. SHASHIREKHA Mundhra to her alma mater. After completing BSc from St. Xavier's College, she did her MSc in Virology from National Institute of Virology, University of Pune, and completed her PhD in Immunology and Microbial Pathogenesis from Cornell Medicine Graduate School of Medical Sciences, Cornell University, New York City, USA. The topic of her doctoral work was characterization of small molecules for host-directed therapy of tuberculosis, which she completed with quite a few good publications. She was a postdoctoral associate in Cornell Medicine till 2018. Then she moved to scientific writing and now associated with Chameleon Communications International for more than 2 years as a medical writer. She is involved in scientific writing, editing, and data analysis to support the development of high-quality, scientifically accurate, and clinically relevant materials that meet the specific communication and educational needs of the pharmaceutical industry. As she is an immunologist and infectious disease specialist, she will be speaking on virology aspects of SARS-CoV-2, followed by the immunology aspects today. The title of her talk today is The Science of COVID-19, an Overview. I believe that her talk will throw lights on many aspects of this infectious disease unknown to us and will make our doubts clear. Another specialty I should mention of Dr. Mundhra is that she is a trained yoga teacher and will be speaking on yoga and meditation, which can help us during this pandemic. So we look forward to her talk. Welcome, Dr. Mundhra.
Thank you so much, Kasturi ma'am, for that wonderful introduction. A very big hi to everyone who's listening. And thank you, respected teachers and everyone in the microbiology department for inviting me to give a talk. Like Kasturi ma'am said, it's an absolute honor to be able to share my knowledge with you all, especially since I started where you guys are right now. Let me share my screen. Okay, so today I'm going to talk to you about the science of COVID-19, an overview. Just a little bit about me. I know Kasturi ma'am already mentioned, so I'll be quick. I, like you guys, did my microbiology honors from Xavier's Kolkata and moved on to pursue my MSc in virology from National Institute of Virology in Pune. Then pursued my PhD in immunology and microbial pathogenesis from United States of America at Cornell University. And now I work as a medical writer, so an assistant scientific director at Chameleon Communications, which is part of the healthcare consultancy group. So just to begin, I'll be touching base on various aspects of this pandemic. So there is a virology aspect, an immunology aspect, an epidemiology aspect, as well as therapeutics and vaccines. So even though I have classified into these 4 sections, they are very much interrelated, and you may notice that throughout the talk. I'll begin with the virology and epidemiology aspects. So just because we have a wide variety of audience, there is diversity. I'll start from the basics. What is a pandemic? It's a disease which affects globally, so the entire world. When a disease is affecting a region, it is just called an epidemic, whereas here it's affecting globally. SARS-CoV-2, also known as the severe acute respiratory syndrome coronavirus 2, is the causative agent of this pandemic. It's the virus which is causing this pandemic, and it belongs to Coronaviridae or coronavirus family. So coronavirus family has many viruses, including SARS, which has caused a previous pandemic as well. Moving on to COVID-19, that is the disease caused by SARS-CoV-2 virus, and this got its name by, this is the acronym, so Coronavirus Disease 2019. I know throughout the talk and also in news, we use interchangeably COVID-19 and SARS-CoV-2, but just remember COVID-19 is the disease, not the virus. So let's meet the enemy, SARS-CoV-2. It is single-stranded positive sense RNA virus, and it has an exceptionally large genome of around 30 kilobases. You may have heard about the genomic part from the webinar on Thursday, so I won't discuss this in detail. For the purpose of my talk, I'll ask you to just remember these 2 important points, that coronaviruses have these spike glycoproteins, which is responsible for their entry into the host cell, in this case, the human cell. And it has several proteins and RNA inside this enveloped virion particle, and that is responsible for its infectivity. So the main receptor via which it enters the cell is called ACE2 receptor. It infects lung alveolar epithelial cells mainly. So as you can see, the spike protein, which by the way makes it look like a crown, that's where the name coronavirus comes from. So it binds to this receptor, ACE2 receptor on the host cell, and that is how it enters the host cell. So what is ACE2? You may have studied this in your biochemistry lesson, but just reminding you again, it's a type 1 transmembrane metallocarboxypeptidase with homology to ACE, which is an enzyme which is a key player in the RAS pathway. This pathway is very important in, say, patients with hypertension or in also cardiovascular diseases. This ACE2 receptor is expressed in vascular endothelial cells, renal cells, lung, kidney, as well as GI tract. But for the purpose, since it's a respiratory virus, it's mostly targeting the lung cells, so lung alveolar epithelial cells. Moving on to the replication cycle. Why is this important? So why do virologists need to know about replication cycle? Mainly one, for research and academia purposes, also for therapeutic purposes. So I'll cover that in the later part of my talk, but you'll notice that when we are designing antivirals or any drugs against it, it's critical to know the replication cycle so that you can target specific aspects of it. So when coronavirus binds to its receptor, it is taken inside the host cell, in this case, the human cell, where because it's a positive sense virus. So the mRNA is directly translated into proteins after the RNA replication. So the proteins inside, there is already a viral polymerase which will cause the replication and transcription. And after multiple genomic RNA strands are created, they'll be translated, and there'll be translation of viral proteins, and then they will be packaged and then finally exited from the host cell by exocytosis. You may have heard this in the news, the word R naught. What is that? So R naught is the average number of people that an infected person can transmit the virus to. So again, I'll repeat, it's kind of a measure of transmissibility of the virus. So it's an average number of people that an infected person will transmit the virus to. So if it's less than 1, the epidemic burns out. If it's equal to 1, then epidemic will continue at a steady pace, so kind of like a plateau. And if it's greater than 1, the epidemic will increase exponentially, which is what is happening now. Current estimates put the R naught for this virus as 2.5 to 2.9, and it's higher than seasonal influenza. Just keeping in mind, seasonal influenza has a vaccine. So every year a new vaccine comes out against the seasonal influenza virus, but currently we do not have a vaccine for coronavirus. So this R naught is also known as the average basic reproduction number, and it's a reflection of both the virus and also human behavior. This is important to understand because this is why interventions such as social distancing and improved hygiene will decrease the R naught of a virus. So for example, you may have noticed that control of spread of COVID-19 in China is kind of a proof that R naught is a modifiable number which can be reduced by effective public health interventions. I think this is where we as scientists or science educators come in, which is like if each one of us decides to spread public health awareness to say your near and dear ones or your friends or your family or neighborhood, it can have an amplification effect, and then everyone is contributing towards public health intervention, ultimately helping in reducing the R naught of the virus. Another example is you may have heard about cruise ships, which were not allowed to dock back in. So one of such cruise ship was Diamond Princess in the United States, where the R naught on board was 15, suggesting that cramped quarters. So a cruise ship is like a cramped place. They have nowhere to go, and there was inadequate hygiene. So it did increase the R naught. So I guess the key takeaway from this slide is that R naught is a modifiable number, and it's a reflection of both the virus and human behavior. Also, R naught can vary between people infected with the virus or depending on their immune response and viral load. So for example, some people carry large quantities of virus. They have a stronger tendency to infect others, and that's why such kind of people are known as super spreaders. So for example, if they are present at a large social gathering, they may lead to dozens of new infections. On the other end of the spectrum, you also have some people who may carry low or undetectable amounts of the virus and with little little risk of disease transmission. Also, it's not possible to know who is a super spreader and who is not, because everyone's immune system is very unique and different from the other, which is why everyone needs to practice social distancing. So just to give you an idea, a comparison to other viruses. So like you can see, COVID-19, I said the R naught is around 2.2. We do have way more infectious viruses such as measles, chickenpox, mumps, HIV, yellow fever, Zika, which have a higher R naught. And this is also a measure of how contagious a virus is. Moving on to another term called case fatality rate. So a simple way to understand this is CFR is the number of deaths divided by the total number of cases, as you can see on the right side of your screen, multiplied by 100. So this is an epidemiologic metric which measures the proportion of people who die from a specific disease amongst all positive cases over a period of time. So this metric is used to indicate the severity of a disease and is also used to measure prognosis of a particular disease. So in this case, until now, again, this data changes every day. And I forgot to mention in the beginning part of my talk that COVID-19 research, again, it's very fluid, changes every day, and these numbers could have changed by now. But this is what we had as of yesterday, at least. So like you can see, CFR for coronavirus, SARS-CoV-2 is around 3.4, whereas other viruses such as bird flu, Ebola, MERS have a much higher case fatality rate. So when you think, oh my God, this is the worst thing that could have happened to the world, no, actually not. There are worse viruses. And if we had a pandemic, say, because of Ebola or smallpox, thankfully it's eradicated, it would have been like 100 times worse. So this is a chart which compares the epidemiology perspectives for various respiratory viral infections. So you have flu, COVID-19, SARS, and MERS. I already covered R naught, which is around 2 to 3. It fluctuates. This data is as of March 2020. But like I said, I think right now it's considered 2.9. CFR is around 3.4 to 4%. For India also, it's going so far as 4%. Incubation time of COVID-19 is around 4 to 14 days. That's why you may have heard this term about the 14-day quarantine period. And like you can see, it differs for different viruses. It's different for flu, SARS, and MERS. Hospitalization rate for COVID-19 is around 20%, and the community attack rate is around 30 to 40%. Again, mentioning these numbers change with time. The annual infected global cases, it's not applicable here because it's ongoing, and I'll show you the data in the next slide. This is as of yesterday, and when I checked this website again this morning, the cases had crossed 11 million. So like I said, the research is very fluid. The number of deaths have also increased. This data is as of yesterday. Like you can see, there is US is a hotspot. India is slowly becoming a hotspot. The top 5 countries are US, Brazil, Russia, India, and Peru. And deaths are also increasing in these countries. However, the number of deaths in India is much less compared to other countries. So another popular term you may have come across is flattening the curve. I would like to elaborate on that. Why is it so important? So flattening the curve involves reducing the number of new COVID-19 cases from one day to the next. And the main point of flattening the curve is that it prevents healthcare systems from becoming overwhelmed. So when a country has fewer new COVID-19 cases emerging today compared to yesterday, then, and this trend continues for a time, I would say at least 14 days, then that's a sign that the country is flattening the curve. Currently, the top few highest number of case by country, you can see that the curve is increasing with time. So India is the red line. If you can, I don't know if my mouse is noticeable, but this is the red line and the cases are increasing. And this slide again compares US and India. And like you can see, as of July 2020, India's curve is also increasing gradually, whereas with US, even though their number of cases, they had a spike initially in mid-March, they were successful in kind of flattening the curve, but then again, there is a spike, as you can see from the graph on the left. So first COVID-19 case in India was reported on 29th January. And since then, our country has reported almost 6,25,000 cases until yesterday, with over 18,000 deaths. These numbers are really shocking, and everyone, that's how we know how severe this pandemic is going on to be. So how does social distancing help? Number one, I mentioned how social distancing can help in modifying the R naught value of the virus, the transmissibility factor. So this is an example. Let's say the pink dot is an infected individual, and if it'll transmit the virus to say 3 others, these 3 will transmit to 9 more, and it goes on exponentially. But if we practice social distancing, say one person works from home, one person didn't go to say a particular barbecue or didn't take a domestic flight, you can see that the curve will kind of flatten, in the sense there'll be less number of infected cases as seen by those pink lines. So how does social distancing help to flatten the curve? So like you can see the red graph, number of cases will almost become double, and there'll be a kind of a spike if no measures are taken to slow the spread of infection. So let's say this is the bar capacity of healthcare system, say for Kolkata is 5,000 beds. Let's say 5,000 beds in the hospital in the city of Kolkata, no social distancing, you may have cases which may be more than 15,000, which means almost 10,000 people will not get adequate care. Whereas if we do have practice social distancing, it'll slow the measure, like with measures where we'll slow the spread of infection. So what happens is that even though the outbreak runs for a longer time, but the capacity of healthcare system is manageable, and you will be able to have the number of, like, you'll be able to, I guess every patient will be able to get at least treatment or admission in hospitals. You may have heard about Mumbai, which is kind of turning out to be an epicenter in India, where there is a dearth of hospital beds. Moving on to the immunological aspects. So before I go into the details of immunology, again, I'll start with some basics. How does the virus spread? So it's mainly a person-to-person, human-to-human transmission. It's between people who are in close contact with each other. So that's why we have this within about 6 feet, which is why Prime Minister keeps saying do gaz duri. Also, it's mainly through respiratory droplets, which are produced when an infected person coughs or sneezes. So it's possible by touching a surface or object that has a virus on it, and if you touch that surface and then you touch your own mouth, nose, or eyes, you may get the infection. This is not thought to be the main way the virus spreads, though. Even Anthony Fauci, who's the head of the pandemic task force for the United States, keeps mentioning that this, even though we are paranoid, this is not the main way. The main way is, like, you have to be at least in close contact with an infected person for at least 15 minutes, and they transmitted by direct coughing or sneezing. So the virus does not penetrate skin. Instead, it enters by mucous membranes, which is why you're asked to not touch your mouth, nose, your eyes, which are open mucous membrane surfaces. The virus enters the respiratory tract via respiratory droplets or aerosol. Symptoms appear in sometimes 5 days or can take 2 to 14 days. So once it enters the mucous membranes, it starts replicating itself. The respiratory tract swells, and then the virus enters the lung and the bloodstream, and further symptoms begin to be seen. So the virus mainly infects, or kind of why is it dangerous, is because it causes direct killing of the infected cells in the lung, and also it can cause an overactive immune response. So one of the main diseases by which it can kill is acute respiratory distress syndrome, or ARDS. So in a healthy alveolus, which you may know, it's a cell inside the lung, unit of a lung. In a healthy alveolus, you have this bloodstream, like you can see RBCs flowing, which also different immune cells like alveolar macrophages, type 2 pneumocytes. These all kind of reside in a healthy homeostasis condition. But when the alveolus is injured, in this case, it could be say, when the virus is killing the lung alveolar cells, then you have neutrophils, which and other innate immune cells that come up. They are all starting to attack, will will send out inflammatory markers, which will cause inflammation of the lung. and then also migrating neutrophils will come into this cytokine play. They'll secrete a lot of inter-inflammatory cytokines, and that is how this ARDS is caused, by the immune system attack. So every individual can get infected, but some individuals are obviously at a higher risk of getting severe disease. So elders greater than equal to 65 years old. So risk of severe illness increases with age because your immune system also deteriorates with age. Healthcare professionals like doctors and nurses, because they are constantly dealing with COVID-19 patients. Other high-risk conditions include, say, chronic lung conditions, heart conditions, kidney diseases, also obesity, diabetes, hypertension, liver diseases, and especially when one's immune system is weak. So, in case of, say, somebody going through chemotherapy, where you are on immunosuppressants, which are drugs which suppress your immune system, or if you've gone, if somebody has undergone organ transplantation or is on, again, steroids, which is a medication to suppress your immune system, then when your immune system is already weak, the virus has a higher chance to cause disease. And also when you are already suffering from other conditions like other comorbidities, there is a higher chance of the virus killing you because your immune system's weak. Pregnant women, there's not enough data about them, so they need to be monitored as the risk for them is not currently well understood. So symptoms of COVID-19, if manifested, include fever, dry cough, fatigue, runny nose, phlegm production, shortness of breath, muscle pain, sore throat, headache, nausea, vomiting, diarrhea, or anosmia. Anosmia means losing sense of smell and hearing. Also, please note there are almost 50% of the times, again, this number is different for different countries, but 50% of the times no symptoms are manifested, but the individual can still be contagious. So you can still be positive for the virus without showing any symptoms, and only a lab test can confirm infection. So can somebody with no symptoms spread the infection? Yes, definitely they can. And this is mostly seen in younger population of who can be asymptomatic and be carriers and spread infection. So there is a variability in the patient journey of SARS-CoV-2 infections. By patient journey, I mean disease progression seen in different patients. So let's say when there is an infection, there can be four scenarios. Either an individual shows no symptoms, which is often seen in about 30% of the people. So they won't have any symptoms, but they'll be contagious for around 14 days, which is the incubation period of the um, virus. And the lowermost axis is the number of days, so the x-axis. But then they'll develop immunity. And in this case, there's almost 0% death rate. Individual can have mild or moderate symptoms. Symptoms is, again, the ones which I just mentioned. What are the symptoms? So around 55% of the cases show mild or moderate symptoms. Initially, they may not show any symptoms and followed by mild, moderate, but they're still contagious, maybe for a longer period of time, and then they develop immunity. Again, usually 0% death rate in this case. However, there can be individuals with severe symptoms, around 10% of the cases, which may need hospitalization, and they will be contagious for a longer period of time because of all the symptoms that they are manifesting. And around 15% death rate is observed in this scenario. And the last part is some individuals which show critical symptoms, in which happens in around 5% of the cases, 4 to 5%. Again, this is why the death rate. And these are the people who actually need ICUs or ventilators. And ultimately, either they manage to fight it off, develop immunity, or they die. And around 50% of the cases who fall in this category do die, which is why 50% death rate. So like you can see, there is extreme variability, and this variability comes from an individual's immune system. So how does one know, and what are the two types of COVID-19 testing? The first is a diagnostic test by RT-PCR, and the second test is a serologic diagnostic test. So the first one is used to establish diagnosis and to identify contagious carriers with or without symptoms. Um, so in this case, it's done by PCR detecting viral load. Samples can be nasal or throat swabs, results in few hours to few days. Whereas serologic diagnostic test, it's used to identify the individuals who were either exposed to the virus or they are presumed to have immunity to the virus or so to reinfection. And in this case, serologic antibody testing is done to detect the immune response to the virus. And samples taken are usually your blood, and results can come in as little as 15 minutes. Because all of you are studying microbiology and other branches of science of undergraduate degree, just wanted to give an idea about how these tests are done very briefly. So the oral swab will be taken when the specimen is saved in viral media. For it can be saved for around 72 hours before extracting the RNA. RNA extraction is a very simple protocol, and many kits are available for it. After you isolate the purified RNA from this deactivated virus, this RNA is what you use to reverse transcribe by the enzyme reverse transcriptase. You make cDNA, and it's amplified by a technique called quantitative PCR, which is very sensitive, and almost all viral load testings are by qPCR. So you use specific probes against certain conserved regions of the virus, either E gene or RDRP gene. And then if a curve comes, then you're considered positive, otherwise negative. Whereas the serologic diagnostic test, if you just understand, it's to detect antibodies in your blood. And antibodies would come up either if you've had an acute infection, or if it's been, you may have had antibodies from the past. Let's say you were exposed to the virus, say a month ago, and you did not show symptoms, but you still will develop antibodies because your immune system will make them. And in that case, it's kind of similar to like an ELISA test, where you'll load a sample onto this test strip. The C stands for control and T for the test sample. And then there'll be an antigen antibody reaction in the strip. That's how they are coated. So like you can see, anti-human IgG, IgM antibodies are coated with it, and they'll have this antigen in the buffers and the test kit. And if you do have an antibody against SARS-CoV-2, you will show a band in the test. And always these kind of tests are performed with a control to ensure that the test is not faulty or not getting a false positive result. There'll also be a control antibody, and you should get a band in the control well. So how do you interpret these results? With C and T, if you see bands in both, it means it's a positive. If you just see a band in the control, means you're a negative, as in you do not have antibodies to the virus. And it's invalid if no band in the controls. So what is the purpose of this testing? Just so that your concept is clear. If you have a positive result, it means you have an active infections and you're contagious. If you have a negative result, it does not mean that you did not have prior infection. It just means that you do not have active infections and you're not contagious. But for antibody, let's say if you have a positive result, means you were exposed to the virus, you may have been protected. You may be protected from reinfection, and you may be protected from the disease. And if it's negative, which means you are probably not exposed to the virus and may not be protected from disease or reinfection. So one of the main management goals of COVID-19 is developing herd immunity. And what do I mean by herd immunity? So when a sufficient proportion of the population has immunity to a given infection, such that it slows or prevents disease spread to protect at-risk individuals, it's called herd immunity. So one way it can be generated is through natural infection, where human body will mount an immune response to the pathogen that is invading their bodies. But in this case, the individual needs to go through the whole disease to acquire immune protection for the future. The other way is to get a vaccine. So, everybody gets vaccinated, which will introduce that pathogen into the body in an inactivated form or some other form, which I guess we'll be learning about vaccines in detail in the next talk. So it introduces, say, the pathogen in the body in a different form, which will not cause the disease, but still enable the human to develop or mount a protective response in a controlled manner. So this chart summarizes principles of herd immunity and social distancing. And if you see, this is the key for on the top right to understand it well. If there is no immunization and social distancing at the onset of infection, you see that infections passes freely amongst individuals. So, you have more infected cases, and in the end there'll be a lot of dead people as by the gray individuals, and many green people who will have the immunity and they'll be fine. Whereas if there is no immunization but social distancing, we'll have isolated individuals which will slow the spread of infection, and the end outcome would be people are practicing social distancing, so less deaths, and some people would have immunity acquired. In the last scenario, when a vaccine does come out and everybody has had the vaccination, infection cannot pass freely amongst individuals because you see most of the people are vaccinated. So in that case, infection doesn't pass freely, and in the end outcome, most of them do have the immunity acquired, and there are less deaths, as you can see by this gray icon. So there is hope, there is help on the way, and we'll talk about therapies and vaccines. So there can be three ways to conduct this management. One, you repurpose existing approved drugs, which is the fastest way. Let's say you have a drug for disease A, and you suddenly find that, oh, it's also working in COVID-19, which is great because you know how to market disease A. It's already in processing, manufacturing. It's approved by the US Food and Drug Administration, so there's no approval process. It's all ready and done. The other way is to discover new therapies, so new drugs like new antivirals or new vaccines. And these last two processes do take time. So we learned about the viral replication cycle in the first part of the talk. So there are several drugs, which are repurposed with potential broad spectrum antiviral activity. So they can be receptor blockers, which prevent virus binding. There are some drugs which can prevent internalization, which means uptake of the virus, trafficking, which means passing of the virus throughout the cell, low pH endosome, membrane fusion. These are again different steps which are needed for packaging of the virus and release of the viral genome. So you can have repurposed drugs which may have potential broad spectrum antiviral activity. Also, there are some clinical phase vaccine candidates for COVID-19 which are currently undergoing. I guess, again, I'll just touch on them briefly because we do have the next talk on just specifically on vaccines. So Moderna is creating a mRNA vaccine encoding the S protein, which is the spike protein, which I showed you in the beginning part of my talk. Then there is another method, electroporation of DNA plasmid by Inovio Pharma, adenovirus type 5 vector, which expresses again S protein. So these are all different vaccine strategies. There's the lentiviral modification of dendritic cells, which is a kind of immune cell. And again, cytotoxic T cells, again, a type of immune cells. These are active against the virus infection. These come into play. And again, there is another kind of inactivated virus vaccine. And these are all different vaccines currently undergoing clinical trial. And there are many more. This is just a snippet to give you an idea that, okay, everybody who is working on vaccines is trying different strategies. WHO was also conducting a solidarity trial where they were trying to repurpose drugs used for treatment of malaria and lupus, like chloroquine, remdesivir, which was used for the treatment of Ebola, and lopinavir and ritonavir, which had been used for treatment of HIV. And this combination with interferon beta, which is again a cytokine used for treatment of HIV. And these clinical trials are ongoing. Some other therapies also which are currently in clinical trials. So again, these four drugs which I mentioned earlier, they are targeting pathogen entry or replication. And then there is another aspect where you target the pathogenic immune response or the cytokine storm that comes into play when your immune system is all activated. Cytokine storm is when immune cells are super activated. Let's, in simple terms again, when an infection is ongoing, let's say you're infected with the virus in your lung, many immune cells will come into play. They'll secrete inflammatory mediators, which are different cytokines, and then you'll need anti-inflammatory drugs, etc., to kind of modulate the response, or any other immunomodulators, which is what these three drugs are. Just this morning, the news came out that Kevzara, another drug, failed this clinical trial. So again, that shows how fluid the research is, and it's ever changing. Some key management strategies. So the Food and Drug Administration in the United States, so the FDA and European Medicines Agency, EMA, these are supporting accelerated development of therapies and vaccines. Even the Drug Controller General of India is doing the same. No therapies have yet been proven to reduce symptoms or to speed up recovery. However, there is variability. There are doctors who've found benefits with using hydroxychloroquine. Some people in the US have found benefits in using remdesivir, but the data is still, I would say, not as concrete because there is variability. So at this time, doctors are just trying what works in their hands in patients. Vaccines are the best approach to achieve herd immunity, and we will need time to develop and test. So even if vaccines are undergoing into phase 2 or phase 3 trials, it is a long shot by the time they come into production and they are given to everyone. And again, I'll let Dr. Chandra Boli cover that part. So opening up the society, when will it be okay to open the society? Personally, I think, again, this is my opinion, when hospitals in a state or a country are able to safely treat all patients that need hospitalization without resorting to crisis standard of care, when at least a state is able to test everyone who has symptoms, a state should be able to conduct monitoring, at least of confirmed cases and contacts, and do the contact tracing. And also, there must be a sustained reduction in cases for at least 14 days. In other words, flattening the curve, when it may be okay to open up the society. So while we wait, what can we do? While we wait for the vaccine, what can we do? Firstly, strengthen our immune system. That's the main player, I think, which we have. It's like our main army, our main weapon against the virus. And this can be done by firstly minimizing fear, panic, and stress. I know it's hard to do that, but still, as they are known to weaken your immunity. Eating a diet high in fruits, vegetables, exercising regularly, maintaining a healthy weight, getting adequate sleep, um, taking steps to avoid infection by, again, maintaining proper hygiene, practicing social distancing and spreading awareness about it, and also practicing yoga and meditation, which is known to improve our immune system. So you might wonder, okay, these are the things I already knew. My mother tells me, my grandmother tells me, I have relatives telling me this, I have teachers telling me this. I just wanted to show you some scientific evidence because each point is backed by scientific study. So people have found that physical activity can change the immune landscape in older adults. So this study did show that physical activity supported healthy aging, especially by helping to protect the immune system from age-related changes. So advise older adults as well to do some physical activity, say in the form of just walking, because I know it's harder for older adults to do some extreme exercises. There is a bidirectional relationship between sleep and immunity against infections. So what happens is when you have a viral infection, there are inflammatory molecules generated. So too strong or too long immune activation will cause disturbed sleep and fatigue. And again, so it's like a feedback loop, but disturbed sleep and fatigue will cause immune system, or kind of immune dysregulation or inflammatory dysregulation, causing your host defense to kind of weaken and then increase infection. So it's kind of a vicious cycle. That's why there's enough adequate literature to suggest that good sleep is important for your immune system. However, if there is an infection, then that a feedback loop is created. Yoga, how does yoga help? I'm sure some grandfather in your family must have told this to you, but it's, again, there is science to back this up. Regular yoga practice has helped in increasing immune function, improving antioxidant status and stress hormone release in young healthy people, as well as this effect has been seen in middle-aged as well as older adults. So this does help all age population, any form of yoga that you practice. Also, there have been studies showing that even brief yoga interventions have kind of had an effect on the markers of inflammation and DNA methylation in chronically stressed women, which I think at this stage most students would be. So DNA methylation is a marker of epigenetics, and even though I won't talk about it in detail, just mentioning epigenetics is like the new thing in immunology research, and they are known to be very critical mediators in immunity. So effect of stress and meditation on the immune system, human microbiota, and epigenetics. So gut microbiome, which is the bacterial landscape is in your intestines, and also epigenetics, which is kind of the modification by, say, methyl groups and others. These are known as very important modulators of your immune system. So what happens is when we are stressed, our body triggers a fight or flight response, and many mediators, many immune molecules are released in this case, which ultimately disturbs the microbiota. So microbiome, again, the gut microbiome in your intestine. So normally when you're not stressed, so in a good state, what happens, this healthy microbiota produces short chain fatty acids, which exert an anti-inflammatory and anti-tumor effects. However, during stress, the gut microbial population is altered, and it affects the regulation of neurotransmitters mediated by this microbiome and gut barrier function. So what happens is when we do meditate, and again, there are many studies, I'm just giving you one example, meditation helps to regulate this stress response, which is this fight or flight response. So thereby suppressing this chronic inflammation, which comes by those secretion of those molecules which disturb the microbiota. So those are suppressed, and then a healthy gut barrier function can be maintained, thereby strengthening the immune system. So to summarize, some key points to prevent spread of infection, which I know everybody knows, but I still would like to reiterate. Social distancing is important. Washing hands regularly for 20 seconds is important. Disinfecting your surfaces at your home is very important, especially the frequently touched surfaces like your cell phone. Practice personal hygiene and be aware of the individuals around you who are at higher risk of getting the infection. Strengthen your immune system. And please remember, you can still be positive for the virus without showing any symptoms. And I know we as science students know this, but you may have some um, people in your family, neighborhood, friend circle who may not be aware of this. So please try to educate everyone you can. And I would like to end by this just a brief chart to summarize what I spoke today. So how SARS-CoV-2 is a virus causing this disease, COVID-19. The symptoms are cough, fever, difficulty in breathing, shortness of breath. It's transmitted through respiratory droplets, and other modes of infection can include prolonged personal contact with infected individuals or touching surfaces exposed to the virus and then touching the mucous membrane areas in your body like face, eyes, or mouth. For prevention and safety, wash and sanitize your hands frequently, disinfect high touch surfaces, and also wear a mask. I know this chart says if you're sick or advised to, but I guess our government has passed this law, and I think people should do this everywhere. Wear a mask all times. Any face covering, whether even if it's a towel or a scarf, if you don't have a N95 or a surgical mask. Self isolate and practice social distancing, so at least 2 minutes or 2 meters or 6 feet apart. Cuff into your elbow or tissues and dispose of tissues right away. So always cover your sneezes. You may not be infected with coronavirus, but if you just sneeze on anybody right now, the person will run away. There's high chances of that. So make sure you're always covering and sneezing in your elbow. Avoid non-essential domestic and international travel. So treatment currently is we don't have a sure shot drug, but of course the regular stuff like staying hydrated and getting rest is important. Monitor your symptoms. So if you reach the severe or critical symptom part, you will have to be hospitalized. But if you're just showing mild and moderate symptoms, do not go to the hospital because there are so many infectious cases there. Just see your doctor, call ahead first. Stay informed by referring to the WHO and CDC websites. And if you develop any emergency symptoms, then please, you or your loved ones or anybody you take care of develops these symptoms, seek medical attention immediately. Thank you for listening. And with that, I'll be happy to take any questions.
Hello.
Yes.
Thank you, ma'am, for that wonderful presentation. And I would request Professor Devjani Datta to conduct the question and answer session and as well as to present the vote of thanks to our speaker.
That was wonderful, Sashi.
Thank you.
That was really wonderful.
Thank you, ma'am.
The science of COVID-19, an overview, was indeed an overview. And thank you so very much for enlightening us with your bit of concern towards this pandemic. Before I conclude, I would definitely give you this session again so that you can answer some of the questions, queries that many participants have addressed over here. I'll go one by one slowly so that you can answer them one by, right?
Yeah, sure.
Okay. So the first question that we have is, what, in your opinion, is the requisite minimum time needed to market an ideally safe vaccine?
So in the past, a normal vaccine has taken almost 8 to 10 years to develop, and this is timeline is reducing slowly, coming up to 6 years. But everything in this pandemic is accelerated. So predictions are currently that by Q4 to Q1 of 2021, we would have at least one vaccine candidate. But again, this is not the norm. The norm, I would say, is 6 to 8 years, ideally. Yeah. Next question.
The second question that we have over here, does the R naught depend on the amount of viral load?
So that is one of the factors, but not the only factor, because the infectivity of the virus and viral load can differ from person to person. So I would say the main play would be, if you have to just think, R naught depends on the virus as well as human behaviors, and viral load is kind of under a human behavior because everyone's immune system is different. So it would be a tiny part of it, yes.
Okay, one more question, I guess, related to our R naught. What is the R naught for the asymptomatic people?
So it doesn't like, you're not measuring R naught for a particular person as such. It's because you don't know how transmissible. I mean, the virus can be still be very have a high transmissibility rate. Even if the person is asymptomatic, the person may be a super spreader. Who knows? So it's hard to measure that. So that's why the R naught value is kind of not measured at an individual, but rather on a community basis. Yeah.
Okay, a few more questions on asymptomatic people.
Yeah.
So is there any relationship between immunity and a person being asymptomatic?
Oh,
Person's
definitely.
immunity.
Yeah. Yeah. In my opinion, I may be wrong, but I personally think immunity has everything to do with being asymptomatic, because your immune system is keeping the virus in check. So some people have, say, not call it a better immune system, let's say a higher activated symptom, so it's clearing the infection faster and not letting the virus stay in the bloodstream enough to manifest infections. However, keep in mind the other factor which can cause an asymptomatic individual is the viral infectivity or the viral strain. But in this case, at least for COVID 19, we know that the strains or the isolates are pretty much similar. So it's not that one strain or isolate is highly infective and one is not at all infective. So far, that hasn't been studied, at least yet. They are finding it similar. Yes,
Okay,
next
thank you.
question.
Thank you. Yeah. Next, we have a question like about animals. Do animals, whether or not they are carrier, and have any chance of contracting the disease or not? And if yes, is it deadly on their part as well? Like, is it for us?
So I'll answer one by one. Yes, animals are
Yeah.
the carriers. Firstly, so at least we were people have found that some SARS viruses, coronaviruses, are carried by bats or by pangolins. So yes, they have been carriers, or they can also be known as maintenance hosts. So you can call them either reservoir hosts or maintenance hosts, and they can be carriers, and that's how by naturally they evolved and it reached to the human transmission. I personally read news that they found a tiger in Bronx Zoo as COVID-19 positive. They also found some dogs and cats as SARS-CoV-2 positive. So I'm assuming that they are finding that it is spreading to animals. However, right now there's not enough research or details known about this. From my knowledge, whatever I'm letting you know is just news articles. So I can't answer the question 100% how dangerous it is for the animals. But yes, they have been found to at least be positive for the virus, several animals.
Okay, Sashi. So we have few more questions.
Yep.
Here again, we have a question like in India, it's a specific case. Again, we are talking about India. We had a lockdown for almost 70 days, but it couldn't flatten the curve. What do you think it is not possible?
So the population, we cannot compare our country's flattening the curve abilities with something like, say, South Korea or say Italy or Spain. Like healthcare standards are different, our population is different, the level of education and awareness is different. So there are many factors. What ultimately flattening the curve means is it kind of gives you time to prepare for the onslaught of the infection. And in our case, because there are so many people, the population is so high, I think our government, I mean, everyone did what they could to try and prepare, get those days were utilized to increase the medical supplies, help have adequate PPEs for doctors, and hospitals were preparing. Like Mahalakshmi race course in Mumbai was converted to kind of a hospital with all beds. So that time was utilized in preparation. I don't think that lockdown went into waste. And it's again a population factor as well as healthcare standards factor.
Thank you. And again, similar on a similar note, we have this herd immunity coming up.
Yep.
So herd immunity in India, which is an overpopulated nation. As a virologist, what do you think we can do to deal with this, to achieve herd immunity?
Yeah. I so please remember, India was a country which eradicated polio. So it's not impossible. Our country has done it despite its large population. Um, Maybe it was Amitabh Bachchan's effect on the commercial, or maybe it was everybody's readiness and to actually take up the challenge and do it. So it is possible, and I think if a vaccine does come out and is available to every Indian, because we do have a huge disparity in our socioeconomic strata, and I hope the government is able to transmit it even freely to poor people. I, as a virologist, think it is possible. because it was possible with polio, and we've done it again with influenza. Slowly, it was every year the number of people who take influenza vaccine is increasing. So I think if there is a combination of government good practices making the vaccine, firstly the vaccine to be available and readily distributed and at cheaper costs, it is possible to get herd immunity. By the time we don't get the vaccine, I think if every individual, every Indian practices wearing a face mask, or practices social distancing, trying not to do go to crowded places or do unnecessary travel. I mean, we do have to work, and I get it, you have to go out, let's say you may have a bank work or something, but just maintaining those practices until the vaccine comes out, it is possible to get herd immunity, in my opinion. Yeah.
Okay,
Next
so
question.
yeah, we have another question here.
Yeah.
So is it possible that by silencing processivity system of TMPRSS2 or ACE2 receptor systems, the COVID-19 virus can be restricted from entering lungs epithelial cells?
Yes, so it is possible, but just try and remember, like, because in our body, it's expressed at so many different tissues. It's any drug, you do not get a complete blockage, um, and also you are fighting two things over here: the virus as well as your immune response in response to the virus. So sometimes it can become overacted in some individuals or immunocompromised individuals, which can cause death. So definitely blocking TMPRSS2 and as well as ACE2 is a good mechanism. I won't say it's 100% foolproof, but then nothing, no drug is 100% foolproof. It's a great mechanism, and I think people are working on it as a therapeutic.
Okay, probably the second last question. What exactly you think is the difference between CB NAT and True NAT?
I don't know that. Sorry.
Okay, okay. So that brings me almost to the last question, Sashi,
Yeah.
which is completely different question. And the question probably you will also be happy to answer.
Yeah.
Students are inquiring how about your discussing about your journey little bit
Oh, sure.
from Javier's to the place where you are. What is your inspiration? So they would also get inspired probably. So you may
Mhm.
enlighten them with bit of
Yes.
your words here.
Yes, absolutely happy to do that. I'll start by the undergraduate level. So I was very much always interested in, say, discovering drugs, something new, something therapeutic, and was always inclined in helping patients. So after I did my microbiology, when we think about masters, I was also very confused, like any other undergraduate student. What should I do my masters in? And I had the option of either trying something broad like masters in biotechnology or life sciences, or trying something super specialized such as virology. Two points which I learned then from my research by talking to older students: if somebody wants to do a PhD in India, where you have to sit for NET and GATE, it's ideal to do a master's in a broader subject because it helps you for NET and GATE preparation. For me, per se, my mother was my inspiration, who always helped me pursue my dreams, and I always stood by me and said, when I told her I wanted to do my PhD abroad, which I was very sure about, she and my parents were very supportive. So I did, when I was giving entrance exams all over India, not knowing what and where I should go. When after the selection results came and I had this choice, I wanted NIV really mm, uh, sort of caught my eye because of their curriculum. It was really interesting, and because now National Institute of Virology is so much in the news, virology and immunology are like the hottest topics now. And I assure you, I did not know this 10 years ago when I signed up for them. I studied them only out of pure interest, because after microbiology, virology was an aspect of it which I found really cool. I used to think viruses are way smarter than humans, and I still think so. So I pursued my master's in virology. NIV gave a great platform to understand what research is about, because it's an ICMR institute ICMR funded institute. So they had every sort of expensive instruments you would call, like a flow cytometer or a confocal microscope, or even biosafety level 3 labs and biosafety level 4 labs, which was the only facility in Asia which they had to research, to conduct research on Ebola viruses. So when I was exposed to all these in NIV, I had this strong inclination to pursue my PhD, to understand more about the host side. I felt that I had done my studies on the from the pathogen perspective, so microbiology and virology, and wanted to study more about the interaction between the two, which led me to pursue my PhD in immunology. I did apply to universities in the US, as well as Europe and Singapore. For anybody worrying about finances, I was also worried then, but I knew that none of these countries, they all give you a stipend which is enough to support yourself for your PhD. So you never have to think about, you don't have to take money from your parents. And also, I mean, except the first stage, which is the first set of applications, as well as the flight tickets. So that was also a factor which helped me be sure of that I would want to do my PhD abroad. When I did get my admission letter from Cornell University, I was interviewed by several people, and then they have a process, at least in the US, they have this process called laboratory rotation, where you can work in 3 different labs and choose your PhD dissertation lab accordingly. Whereas this process is different in the Europe. You apply, instead of applying to a university, you apply to a professor directly who may have vacancy for PhD. So in this case, when I worked in 3 rotations, it has to be a mutual fit. The advisor has to like you, and you have to like the advisor in the lab. And during that process, I decided to work on tuberculosis, so host defense against TB, and where I got to do both parts, which is study the immunology aspect as well as the bacterial aspect. After I finished my PhD in 2017, I was just doing, continuing the postdoctoral work, mainly to complete and wrap up my publications. And that is when I went to a conference which was held in New York University, called What Can You Be with a PhD? And it was an eye-opening conference, because I think me at least, when I was in India, I didn't know that you can do so many different things after your PhD. It just doesn't have to be, say, academia. After your PhD, you need not just become a professor or have your own research lab or teach at an educational institute. Instead, you can think about becoming a medical writer, or think about go into consultancy, or think even become an equity research analyst after a PhD. You can also go into a pharmaceutical company and do an industrial postdoc, or you can go and into like becoming an editor, for a scientific editor for a journal like Nature, Cell Science, or any journal, peer reviewed publications. So almost 25 career options opened up for me during that conference, and I was lucky I was exposed to it because I was in New York City, else I would not have known about it. And that's when every panelist would tell them how a day-to-day life would be like of their profession. And the medical communications panel excited me the most, because they highlighted the way their day went was exactly, I thought, were my strengths, which was I like giving presentations, simplifying complex concepts into simple tasks. And if you had teaching experience, which I did have during my PhD, you are considered kind of at an advantage to be able to become a good medical writer, because it's all about communications. And that's how I then started giving interviews. When I was applying for jobs, I was also very confused, and I tried everything. I did try being a postdoc, so I did do some bench work after PhD. I also taught as an adjunct professor at a college, undergraduate college in Manhattan, where I did my PhD, and I taught human biology. So I did get the teaching experience, and I also tried medical writing after that. And I found that this was what excited me the most, because what I do at a day-to-day level is our company's clients are pharmaceutical industries, and every day is unique and different. So we can work on different therapeutic areas. I constantly learn about the new research. My main job is scientific accuracy, which is condensing, I would say 50 journal articles into, let's say, 10 slides in a presentation. um, and these sometimes I make educational modules which are used to educate patients and nurses, or which come on their medical information website of a drug. Every drug has a medical information website, and often these companies sponsor these educational modules, so where the patient can just learn about, say, if they have diabetes, or if they have a cardiovascular disease, or if they have rheumatoid arthritis. So it's mostly the science aspects. I still get to do science and research, but just in a different format, not bench work. And this medical communications part, which I work on, is called continuing medical education, which is different from promotional medical education. So that is the marketing aspect of the drug, which is a separate branch, which I don't do. So that is what medical writing is about. And also, I'm happy to share my, say, LinkedIn contact as well as email address. If any of you have any other career related questions, I'll be happy to answer, say, via email or via LinkedIn chat. So feel free to reach out. I was in your position one day too, and got the help that I needed in the right places. So thank you.
Thank you once again, Sashi. Uh, well, to conclude, I would say it was a terrific talk, very lucidly explained on the current scenario that we are at with the COVID-19 pandemic affecting everybody, be it a child, be it an elderly person or younger generations. Everybody is so terrified going out for work. Same with me as well. So what you did was very easily explained the various aspects of COVID. You began with virology, giving us a overview on how exactly it works, how exactly it enters, talking about the epidemiological perspectives. Whatever we know, we are hearing from news, but then from you into proper slides and proper presentation. It was a crisp understanding of what exactly is happening around the world as well as in India, the immunological aspects, covering the details, as well as finally moving into the therapeutics, wherein talking briefly about the vaccines. I'm sure you know you also said that later Dr. Chandravali is going to cover on this, and maybe the touch on the yoga meditation, which probably might also boost up the situation right now that we are in. And overall, the simple words or terms that we have been associated with these days have been also well explained. What is exactly flattening the curve, social distancing, and everything has been touched upon so well. I guess it was a very concrete and crisp presentation, and everybody who heard you probably had a good understanding as your and even justified topic, the science of COVID-19 and overview. We are thankful to you for sharing your experience and your talk with us. Thank you so much.
Thank you so much, ma'am. Again, thank you to the department for inviting me. And just one advice for all students: what you can do while where you are. I strongly remember all the professors in Xavier's helping us participate in Indian Science Congresses, and we did so many research projects and poster presentations, and they all helped me in my application for PhD. And I know the pandemic situation is different, but if possible, try to do as many research projects as you can. And yes, I'm sure the teachers were so supportive. I'm sure they'll support you guys as well. So good luck with everything. Bye.
Thank you, Professor Devjani Datto. Thank you, Dr. Kasturi Sarkar, and as well as our very own alumni, Dr. Shashirekha Mundhra, for not only enlightening us on the COVID scenario, but also walking us students through your journey. Now we'll be going on a short break, and we'll be returning with our final speaker, Dr. Chandravali Datto, and it will be around 5 o'clock. So until then.